morning, guys. It's grade 8. Today, inshallah, we're going to pass the lesson 2 of chapter 13. We talk about the properties of solution. Last time, we studied already the difference between the mixture and the compound, and we know different types of mixtures. And we said mixture is just a physical blending of two or more substances in which they are physically mixed, no chemical combination happening between them, no result of new chemical substances, just still the same components, but just mix it together. And we said regarding to these, there are two types of mixtures. It could be heterogeneous mixture or homogeneous mixture. So the heterogeneous mixture, the mixture in which the components are not eventually distributed together or easily to differentiate between the components. While the homogeneous mixture is the mixture which have similar or uniform outfit. That means have one appearance. I can't distinguish its component because its components are eventually distributed to each other. Today we're going to talk about the solution, which is an alternative name for the homogeneous mixture. So what are the objectives of our lesson? First of all, after the end of this lesson, we should be able to answer the following questions. Why do some substances dissolve in water and the others do not? How do concentration and solubility differ? And finally, how can the solubility of a solute be changed? So the new vocabularies which we're going to learn in that lesson: solvent, solute, polar molecule, concentration, solubility, and saturated solution, unsaturated solution. So actually most of them, they may be new words except concentration, but we're going to know what the meaning of these terms during our lesson. So let's start here. So actually, what are the parts of a solution? So we can say any solution is made of two parts, two components, solvent and solute. So what are solvent and solute? Because solution is a homogeneous mixture, so we're gonna have two components, at least two substances. They are gonna be mixed together, and they must be eventually distributed. Okay. So that means we are gonna have a substance that dissolve or hide in another one. So the substance which dissolve or the substance which found in a small amount and could hide in another substance which found in large amount. So the small one, we call it the solute, okay? That's the substance that could dissolve in the solvent, okay? So like this, we could say in a solution made of solvent and solute. Solvent, the substance that exists in the greatest amount or the greatest quantity of the solution, in which the solute can hide in or distribute it between its particles, okay? Or dissolve, that means break down into small particles that found between this. For example, when we have salt dissolves in water, salt is the solute while water is the solvent. Water found in the greatest amount, the particles of the salt will break down and hide between the particles of the water. So salt is the solute while water is the solvent. So here, let's see here, guys. So what are types of solutions? Types of solution actually depend on or can found on three states. So it depends on the state of the solvent. So the solvent can be solid, liquid, or gas. So like this, also we are gonna have a solution as solid, liquid, or gas. So why the type of solution depend on the solvent, not the solute? Because as we said, solvent the component of the solution which found in the greatest quantity. So if the solvent is liquid, so the solution will be liquid. If the solvent is solid, so the entire solution will be solid. If the solvent is gas, so the entire solution will be gas. So like this, the type of solution depends on the state of the solvent, because the solvent is the one found in the greatest quantity. So here let's take some examples to clarify the idea. For example, if we have the solvent is solid, so the type of solution also is going to be a solid, okay? So let's take an example. Actually, the examples are alloys. Okay, so what are alloys? Alloys actually they are mixtures of some gases and solids or metals, okay, or some metals together. So that means if we have a solvent, a solid, so the solute could be gas or solid, cannot be liquid, okay? So here gas or solid that could dissolve in another solid. For example, let's find here, okay, do you know the gold, okay, when you go to buy some jewelries, okay, so you may hear that there's different types of gold. There is gold which is cart 14, cart, okay, 21, and so on. So these numbers refer to what? Actually, natural gold or pure gold is very, okay, flexible metal. That mean could be easily broken by your hands. So of course I can use it to make jewelries in that state, because imagine that you are gonna wear your ring and you just smash it with your fingers. So it cannot work. So in that case, we need to mix gold, okay, or to make a kind of solution, okay, in which this gold mixes with another substance that make it a little harder. So here we start to make alloy. We just gonna add some silver and some copper to the gold to make the gold alloy, which make it a little harder, okay, than pure gold. So in that case, we have solid that dissolve it in another solid. That means the copper and the silver, okay, they make it they consider a solute that will be dissolved in the gold, which is a solvent. Okay, so solid dissolved in solid. Also, okay, the saxophone and most of the metal wind instruments, okay, they are made of brass. Brass is a kind of alloy that is made of copper and zinc. So zinc is a solid that dissolves in copper, which is another solid. Sometimes they may could be a gas dissolved in solid, like sometimes creating a kind of metals like spongy iron or something like that, okay, which contain some gases, okay, they are already dissolved in the iron itself. So here, like this case, that represent the idea that we could have a solid solvent in which a gas or a solid solute dissolves in, so they are going to create a solid solution. Second type, which is the most common one, and the one which you just imagine when we say the word solution, which is a liquid solution. Liquid solution, it's a solution which formed once the solvent is liquid. And once the solvent is liquid, so the solid could be solid, liquid, or gas. That means some solids, some liquids, or even gases, they have the ability to dissolve in liquid solvents. So for example here, like when you get some of salt and you just dissolve them in water. So like this, the solute is salt and they dissolve it in the solvent, which is the water is liquid. So it's a liquid solution. The solvent is liquid while the solute is solid like salt. We have liquid solution, for example, like when you dissolve the alcohol. So alcohol, for example, can dissolve also in water. In that case, alcohol is liquid and the water is liquid, so it's a liquid solution. Okay. For the third thing here, gas like carbon dioxide. Okay, when carbon dioxide is mixed with water, carbon dioxide that could be mixed in like in fizzy water, like Pepsi and something like that. So that's also the kind of mixture. So in that case, here we could find the gas could dissolve in a liquid. Okay, so here that represent the liquid solution. Why we could liquid? Okay, although the solid is could be solid, liquid, or gas, because the solvent is liquid. So the last one, or the last time, the gas solution. In that case, the solvent must be a gas, and once the solvent is gas, the only possible thing that could dissolve in a gas is another gas. So we cannot dissolve solid or liquid in a gas actually. So in that case, gas solution. So in gas solution, in that case, here we're gonna find, for example, the atmospheric air. Okay, so the atmospheric air, or the air which we have in our the life that we already live on the earth. We are surrounded by this atmospheric air. It's a mixture of gases in which many gases are mixed together, okay, to form this kind of solution or homogeneous mixture. So nitrogen, considered a solvent, the most common gas in the atmospheric air, while oxygen, carbon dioxide, and some other gases, they are blended within that nitrogen, or they are somehow they eventually distributed within the nitrogen particles. Okay. Also, for example, do you know the lighting signs that contain so in the markets and something like this? They contain a lot of gases. Okay, like argon and neon. Okay, xenon. They are many gases mixed together just to produce this different lights. So here, like this, guys, that's represent the idea that we determine the type of solution based on the state of the solvent. So if the solvent is solid, so the solution will be solid. If the solvent is liquid, the solution will be liquid. If the solution is gas, so the solvent will be a gas. If the solvent is gas, so the solution also will be a gas. So here then, water as a solvent. Actually, water is very, very important and unique one, okay, or unique substance, because it has a lot of characteristics. One of these characteristics that water is considered to be a common solvent, or we call it the universal solvent. Why? First of all, water could find in three different states: solid, liquid, or gas, which make it unable to make different kinds or different types of solution. That means solid or liquid or gas solution. Also here, water is polar. Okay, what mean by polar? That means water has the ability to dissolve most of the ionic and the polar compounds. It could able to dissolve a lot of solutes can dissolve in water because of this of water polarity. Let's see what mean by water polarity. So let's just look with me here, guys. We know that water is H2O. Water actually, or the natural water we can find in nature, we can never find just in H2O, because water in nature is found in form of homogeneous mixture in which a lot of minerals and solids they already dissolves in water. Like for example, when you pick a pour of water and just read the label on it, you're gonna find contain potassium, magnesium, sodium, a lot of minerals dissolved in water. Okay, so that means water is already in nature as a homogeneous mixture or a solution. So what make the water able to dissolve all these different materials? Okay, so let's find this unique structure of water, H2O, which means each water molecule is made of one oxygen atom. This oxygen atom is bonded with, okay, covalent bond with two hydrogen atoms. Okay, so the oxygen is bonded with hydrogen. So what the problem here? Okay, there is no problem, but let's find a fact. As it's covalent bond, it means already the oxygen and the hydrogen, they are sharing electrons of the outermost energy level. So there are two electrons that are found between the water and the hydrogen, or the sorry, oxygen and hydrogen in the water. But as we know, oxygen is a bigger atom, has more protons in its nucleus than the hydrogen, which means the positive charge at the center of the oxygen is more than the positive charge, okay, or the more than the protons found in the hydrogen, which make oxygen is able to attract the electrons of the bond more toward itself. So like this, the electrons will spend more time beside oxygen rather than hydrogen. In that case, the area around, okay, the oxygen will be slightly negative, while the area that surrounds the hydrogen will be slightly positive, which means the water is charged. No, water is not charged. Water is neutral. Any compound is neutral because the number of electrons equals the number of protons in any compound, so it's neutral. So what meaning by polar? Polar, that means we have unequal distribution of charge. The charges are not at the half distance between oxygen and hydrogen. No, the charges actually are more closer toward the oxygen. And as electrons are negatively charged, so and they spend more time beside the oxygen, that make the oxygen slightly negative, while the hydrogen is slightly positive. So like this, water is polar. Polar, that means it has unequal distribution of charge, in which a region of water, which is oxygen, is slightly negative, while the other region is slightly positive. That is the polarity of water, or like this, we could describe water as a polar compound, okay, or polar molecule. So this polarity actually make the water is a very good solvent that could able to dissolve a lot of ionic substances and a lot of polar, okay, substances. So let's hear it, guys. So we see that water is polar molecule, okay, because it has a slightly negative region and a slightly positive region or end. So here, for example, we find the oxygen will carry slightly negative charge because it's able to attract the electrons more toward itself, while the hydrogen will represent a slightly positive end or slightly positive pole because they are not able to attract electrons. That means electrons are further from them, so somehow they are slightly positive. Regarding to this polarity, let's watch how water could affect this solid. So actually, we need to find that polar, as we explained, they have two regions. Okay, one is slightly negative and the other positive. While non-polar molecules, okay, they have even distribution. That means the electrons of the bond, they are found at half distance between the atom. So no part is negative, no part is positive. So non-polar, completely the opposite of the polar compound. So how that could affect the dissolving of solutes in water? Okay, so here, like dissolves like. What does mean? That mean water always, okay, because water is polar, so water is able to dissolve that charged, okay, or the ionic compounds, which is already made of ions, positive and negative, like sodium chloride, for example, the table salt NaCl. Na is a positive ion, okay, Cl is a negative ion. They are attracted to each other by ionic bond. So the R is dissolved in water because water is polar. That means water already have an equal distribution of charge that enable it to dissolve ionic compounds and the other polar compound. So because water is polar, always is going to dissolve the polar compound. So polar solvents like water dissolve polar solutes easily. And non-polar solvents, okay, for example, non-polar solvent like, for example, chlorine, benzene, okay, and something like this. This, okay, non-polar, which means they don't have these ends or these no slightly charged balls, okay. So like that, they will not be able to dissolve the polar solids. So here, water as its polar solvent, so it could dissolve all the ionic solids and the polar compounds. And in that case, okay, we call the water is ionic, okay, or we call the water is a common solvent. So let's find what happened actually during the dissolving, okay, of ionic compounds in water. So simply here, we're gonna find once you just add, okay, for example, when a polar solute such as okay, rubbing alcohol dissolves in water, that means when we add alcohol in water, it dissolves. Why it dissolves? Because alcohol is polar. Polar, that means it's already have two, okay, or have unequal distribution of charge. That means have a slightly negative charge, slightly negative pool and the slightly positive pool. So here, let's see. We're gonna find here the negative end of the water, which is the oxygen, is gonna be attracted to the positive end of the alcohol. Okay, and at the same time, the negative end of the water is attracted to the positive end of another water molecule by something called the hydrogen bond. Okay, so later here we're gonna find the positive part of the water is gonna be attracted to the negative part in the alcohol. So that will create a kind of attraction force between water molecules and each other, and same time kind of attraction force between the water molecules and the alcohol molecules. So as water, okay, already moving, or the water particles are moving, they are gonna hold it there, okay, or they are gonna hold alcohol molecules with them, and they start to move further from each other, which make alcohol somehow dissolve in the water. Here, once we look to in the case of ionic compounds like table salt, for example, you're gonna find here that the table salt is made of sodium okay, ions, that's which in silver color or gray color, while you're gonna find chlorine, which is a negative ion that made in green color. So once we drop a piece of salt in the water, we are gonna simply observe that the positive part of the water molecules, the hydrogen part, will surround the negative ion or the chlorine, while here the negative part of the water, okay, which is oxygen, is gonna surround the positive, okay, sodium, and they will just set them apart, or just gonna dissociate this cube of salt into simple ions of chlorine and the sodium, in which each ion is surrounded by water molecules and prevent them to attack each anymore. So like this, the table salt will break down and completely dissolve in water. So here, like this, guys, that represent the solubility of water and how water could serve as a common solvent, for the ability of water to dissolve a lot of substance. But the most important condition for any solid to be able to dissolve in water, this solid must be polar or ionic, because we know that water is a polar compound, or water is a polar solvent, so it dissolves only polar and ionic compounds. So here that the part which we're gonna step at, guys, today. Next time we're gonna continue our lesson. Please study this part very well from your textbook, and if you have any question, I'm waiting for your question. Thank you, guys, and goodbye.